Hello everyone, this is Atoms Measures tutorial program. Okay, so today we have this interesting topic which is Unit 4 or Chapter 4 for your Term 1 test. This is the last chapter, which is called dynamics. So this is part of the problems that you are going to cut when you go in detail of dynamics. So this is the second part. The first part, that one which deals with the inclined planes, where you have to resolve here and there. Then this is the second part. Then the last part is about the static equilibrium, or what you can say a torque. There's torque and equilibrium. And where you find those questions of a radar and the like. Alright, so we have this question which says a traffic light weighing 100. The traffic light is weighing 100 Newton, hangs from a cable tied to two other cable fastened to a support as shown here. Then the question goes further and say the upper cables makes angles of 37 and 53. The upper cables, these upper cables are the one that is making these angles with what? With the horizontal. Find the tension in the cable, in the three cables. Find the tension in the three cables. Okay, so this question, you can solve this question using two methods. As we have indicated in our document, we can solve this question using two methods. The first method is the resolving, the same thing you used to do when you are doing vectors. And then the second one is now where we use what? A trig. The trig method. This was discovered by certain scientists, and everyone uses this formula. And the answers, if you use the resolving or the trig, the answers are are the same. Okay, so let's say this is our tension 3. This is our tension 3. This is our tension 1. And this is our tension tension 2. Okay. Okay, sorry for that. Okay, then we have been told to find the tensions in the three cables. I would have said cables, in the three cables. Okay, so since there are two methods, the first method we said is the one that involves the resolving method, and this one is what? The trig method. So since we already know this method, we are going to apply the trig method, just to make this interesting and more fun. All right. Okay, so this trig method, the formula that we imply here is what? The sine law. So from the trig we get only what? The sine law. And then we apply the sine law to this question for us to solve what? The tensions. Yeah, you know that the tension is the force applied in the cable or in the rope. Yeah, so the sine law from your grade 12, we say that sine law states that a the distance of a should be over the corresponding angle of a, which is equal to b over the corresponding angle of b, then which is equal to c corresponding angle of what? Of c. Yeah, so that means that this is supposed to be equal with that, and this is supposed to be equal with what? With that. Okay, yeah. So these things also this formula also applies to that problem. Okay, so how can we now apply this concept or this law to this question? All right, so if you see this T1, this T1, the corresponding angle is this one. So when we are plugging T1, its corresponding angle, so it should be the angle facing it. Okay, then T3, also the angle facing it. Just going to use let's just use 3 lines. T3, its corresponding angle, then T2, its corresponding angle as well. Okay, so this thing or this traffic light, it's at equilibrium, meaning that it's balanced. You get that? Yeah, it's balanced, and the summation of forces both in x and y, they're equal to 0. If you use that formula for resolving, you apply those things, those stuffs. Okay, just to remind you. Okay, so since we know that this traffic light is weighing what? Is weighing what? Is weighing 100 what? 100 newtons. Okay, weighing 100 newtons. So just get this come apart. This part, we draw a free body diagram. This is a traffic light. You draw a free body diagram, and this is weighing what? 100 what? 100 newtons. Then this is our T. This is our T3. Then there is a down pulling force, which is what? Which is weight. Okay, then this is a positive force, this is a negative force. Okay, and since it's at equilibrium, the summation of the forces in the y should add up to what? To 0. Okay, so we can say that T3, tension 3, which is a positive force, then minus the weight, which is a negative force. That's making it to be negative because it's going down, or it's putting the traffic light down. Okay, which is equal to what? Which is equal to 0. Then T3 will be equal to the weight, and we know that this weight is the weight of the what? Is the weight of the this weight is the weight of the what? Is the weight of the traffic light, meaning that automatically T3 is equal to what? Is equal to 100 newtons. Okay, simple. See, simple. Okay, so since that we are capable of finding T3, that means that now we can go ahead and find for T1 and T2, and our problem will be solved. Okay, so Okay, from here now we can continue to say T3 over the sine of angle of what? Of T3, or the corresponding, should be equal to, let's find T1 over the sine of the corresponding theta of what? Of the tension of what? Of T1. Okay, so now here we apply now what? The math, what we learned in grade 12 primary. Yeah. Okay, so here we try to cut an horizontal line. Okay, horizontal line. Then this angle is corresponding to this angle. This angle from the grade 12 work, and this angle is corresponding to this angle. Meaning that if I have 37 here, even here I have what? 37. Then if I have 53 there, even here I have what? I have 53. Okay, so then if I have 37 there and I have 53 there, then what angle am I going to have here? So this is a straight line, and you know that supplemented angles add up to what? Add up to 180. So this plus this, it's going to give you 90. 90 subtract from 180 is what? It's 90. Okay, or we can add up this, and you subtract from 180, you're going to give you that when you apply the summation of what? Angles in a triangle. Okay, so having find these two angles, then automatically you will know that here it's making a 90 degrees and there it's making a what? A 90 degrees. So which means this angle is 90 and that angle is what? Is 90. Okay, so then now we know that as we are interested in O of this angle, and O of that angle. Okay, so this corresponding to that, which meaning that this angle is what? Is Q1. So 90 plus 37, you're going to have what? 127. That makes Q1 to be what? 127 degrees. And when you add 90 plus 53, that's what we are going to get. Q2 will be what? Will be 143 degrees. Okay, and this makes everything more interesting. Okay, so now we have found the angles and the corresponding sides. Now it's just a matter of what? Plugging in. Okay, so T3, the tension of 3 is what? We found what? To be what? To be 100 newtons. So T3 is 100 newtons. Then the corresponding angle for T3 is what? Is 90 degrees. Is 90 what? Is 90 degrees. So this will be the sine 90, which is equal to T1. This one, T1, we don't know it. You're looking for it. T1. Then the corresponding angle of T1. The corresponding angle of T1 is what? 127. So sine 127. Okay, from there now we just do what? The cross multiplication, and we make T1 to be the what? To be the subject. Okay, so T1 sine 90, which is equal to 100, then sine what? 127. Okay, then we know that sine 90 is what? Is 1. So then T1 is equal to what? So we say 100. Let me use my calculator. Say 100 sine 127. 100 sine 127. It's giving us what? 79.86 newtons. So this is what? Is T1. Then Once you find T1, now you go further to find what? To find the T2. So use this complete side again. If you want, you can even use the T1, since according to the sine law, A over the corresponding angle of A is equal to B over the corresponding angle of B, which is equal to C over the corresponding angle of what? C. So everything is what? Is equal. Okay, so you can say T3 over sine theta of 3, which is equal to T2 over the sine theta of what? Of 2. Then from there now we can say our T3 is what? Is 100 newtons over sine. The theta of T3 is what? Is 90. Okay, which is equal to T2. You're looking for it. Then sine the angle of the corresponding to what? To T3, to T2, sorry. So T2, its corresponding angle, this is the T2, the tension of T2, this one, its corresponding is what? Is this angle, and we know that this angle is what? Is 143. So we are going to have 143 there. Okay, so then from there now we just do the cross multiplication and we make T2 to be what? To be the subject. All right. Yeah. So then we know that sine 90 it's 1, so we make T2 is equal to 100 sine 143. 100 sine 143 is going to give you 60.18 newtons. Then Yeoman dry. Then T1 was 79.86 newtons. Then T2 is 60.81 newtons. Then T3 was 100 newtons. Okay, these are our solutions. Okay, so even if you try to use that resolving method, you're going to find the exact and same figures of the tensions in the cables. Yeah, so I hope this video has helped you in some way. Yeah, and you have understood the concept behind solving equilibrium questions under dynamics, yeah, using the Trig method. Okay, thank you very much, and see you soon in class.